Hi, and welcome to the Kubernetes podcast from Google. I'm your host, Abdel Sigiwar.
And I'm Caslin Fields.
Imagine trying to move millions of compute cores and thousands of microservices to a brand new platform, all without dropping a single user request, ride, or delivery. Sounds like an absolute logistical nightmare, right? Well, today we're sitting down with someone who actually lived to tell the tale. Lucy Sweet is a staff software engineer at Uber and the lead for the Kubernetes node Lifecycle working group. In this episode, we're diving deep into Uber's monumental infrastructure journey, moving away from their in-house system to Kubernetes. We'll be unpacking the reality of running this at scale, why it's always DNS, and why building things for fun is worth it.
But first, let's get to the news. Broadcom announced they're donating Velero to the CNCF at the sandbox level. Velero is a Kubernetes native backup, restore, and migration tool. It traces its origins to Heptio, which was founded by former Google engineers Joe Beda and Craig McLuckie, and acquired by VMware and eventually Broadcom.
The CNCF released the KubeCon and Cloud Native Con Amsterdam 2026 Transparency Report. This edition became the largest event in CNCF history with over 13,500 attendees, 46% of which were visiting KubeCon for the first time, representing 100 countries and over 3,000 organizations.
The call for proposals for KubeCon Cloud Native Con North America 2026 is open and will close on May 31st, 2026. The event will take place in Salt Lake City, Utah, November 9th to 12th.
OpenCoreo released version 1.0 to the CNCF sandbox. The project originated as the open source counterpart to WSO2's commercial Coreo SaaS platform and is designed to give engineering teams a complete foundation for running workloads on Kubernetes without requiring them to build it themselves. It includes a backstage-powered developer portal, built-in CI/CD, GitOps workflows, observability, and what the project calls a programmable control plane.
And that's the news.
Today, I'm talking to Lucy Sweet. Lucy is an engineer at Uber. She is part of the team responsible for building and maintaining most or nearly all the platform infrastructure used by engineers globally at Uber. Lucy is also a Kubernetes node lifecycle working group lead. Welcome to the show, Lucy.
Thanks, and thanks for having me.
So I'm very happy to be here. It took us quite a bit of time to get this kind of together so we can talk to you folks. This is part of our series interviewing end users of Kubernetes. This is like a feedback we got for the show. And we want to talk to you a little bit about your, Uber journey and your personal journey through moving to Kubernetes, right?
Mm-hmm.
So you did a talk a while back. I think it was KubeCon during COVID time, if I remember correctly.
Oh, wow. That's like a lifetime ago at this point. Jesus.
Yes, feels like ages.
Yeah. Was I even alive back then? My word.
Yeah, and part of your talk was talking about the story of how Uber migrated millions of cores to Kubernetes.
Mm-hmm.
Can you talk a bit about that? Like, what's the triggering points to converge to Kubernetes?
Yeah, absolutely. So we originally at Uber have been running separate stateful, stateless, and batch compute platforms. So we have a stateless platform called Up, a stateful one called Odin, and then there's a batch one as well, and so on. And none of these used to use Kubernetes. The stateless one was built on a system called Peloton, which came into existence literally like a decade ago plus, and it came into existence around the same time as Kubernetes. It is a bit different though. Peloton was built on Mesos and was a bit more workflow based rather than reconciliation based. Mm-hmm. And we happily used that for many, many years. But over time, Mesos started to be less and less actively developed and maintained. And also we saw where the wind was going. We saw that everyone was converging on this one platform, and that brings you a lot of benefits. When you're on the same platform as everyone else, you get a lot of network effect, and you don't have to build solutions to common problems that everyone else has also already had. So back about 3 years ago now, we decided to move our stateless compute fleet to Kubernetes from Peloton. And that process all kicked off just actually as I started to join Uber. So today we've got our whole stateless fleet on Kubernetes, and I'm sure we'll talk a bit more about that as well. And we're just starting to move our stateful compute stack over as well, because we had such a good experience with the stateless one. We were like, okay, well, why not go further? Why not do more?
Nice. And so I was reading some of your publications on the engineering blog of Uber, and one thing that I found very, very entertaining, very cool actually to read is the story of the migration. So migrating millions of cores, I assume hundreds or thousands of microservices without downtime. At the scale of Uber, I assume it's a very complex thing. That's essentially like if Google decided, we're going to move from Borg to Kubernetes while keeping Google alive, right?
Well, when are you guys going to do that?
That's a very good question. I am in Bergen at Cloud Native Bergen, and somebody literally asked me the same question today. Like, when are you guys moving to Kubernetes? So what's in your mind have been the key to success for that like specific migration, like migrating without downtime, right? Like what have been some lesson learned patterns, things that you have kind of learned through that journey?
Well, one of the first things I think that we kind of had to pay our technical debt on was that we didn't have this property called portability. So a lot of our services were dependent on, I have to run on like this machine, and if I'm not on this machine, then everything breaks. Or, I have to bind to this like static network port. So if someone else tries to bind to that network port, everything goes wrong, right? And this, before the migration, was all over Uber, and it was everywhere. It took over a year from memory of basically pestering people to undo this. The way that we tried to do it was we normally, with every migration, and in fact every upgrade of every service at Uber, do something called make before break. So we try and start new containers of the application on whatever new stack we're running, or if there's a new version upgrade with like the new container image on the same stack. And then we only start destroying the old version when that new version has come up fully, and when all of the health checks and everything's passing, when end-to-end tests have passed, these sorts of things. And we use that pattern to actually find services who we thought were not portable. Because what we can do is we can say, okay, I'm going to try and spawn a container of your service on K8's cluster, and let's see if you come up. Let's see if your service immediately, does it exit one? Do the health probes pass? Does the end-to-end test pass? If they don't, we just back off, we take the new version on K8's away, and then they end up on a long tail. And eventually, you can keep trying on that long tail automatically, but eventually it gets to a human, and a human has to go to the service owner and say, hey folks, why does your application not work on K8s? What crazy stuff have you done this time? That process, took over a year to get to. But that portability is so important, and we keep using it now. So, for example, we used portability once we got it to migrate to K8s. But more recently, we also looked at, our entire fleet is on AMD 64 Arch CPUs. We want to start using ARM. ARM's cool. Okay, well, because we already have this portability trait and we have this make before break trait, we can kind of make this touchless to service owners. We can just start trying to spawn them, make before break style, on CPUs. And if it breaks, not a problem. We'll just take the new containers away. If it doesn't break, awesome. We can put them on ARM. And we can do that without actually having to talk to service owners at all, really. We only talk to them if we need to move them, and their service won't.
Got it.
But at least for me, it's very easy to lose portability in a company if you're not always looking out for it, just because of Hiram's law. If you give someone a way to depend on a host at scale,
they will do it.
Someone will depend on a host.
Yes.
I've seen this far too many times. I'm guilty of this sometimes.
It's quite interesting, actually, this whole concept of portability. I'm curious about something. Like, I understand the concept of like spinning up the service and trying to see if it works and it's past testing. But like, how do you handle it from the traffic point of view? Is that like a blue-green deployment kind of thing, or?
So network traffic can be always a bit of fun. So most applications at Uber have something called Canary. So we send 1% of the traffic to like the Canary/new version. And then the idea is that if that messes up, if that fails, we can always retry. Obviously there are error cases where It's not just a binary, it errored, it didn't. But most of the time, that's good enough.
Yeah.
And that's solvable. We do provide customization for our users, but honestly, most users don't have to touch that. At least when we build our platforms, what we're trying to do is build them into a way where as a user, you just want to write code and move on with your life.
Yeah.
Like our end users who build like the Uber app, if they shouldn't have to care about like, what machine I'm on, what my network traffic looks like, what my scaling looks like. It's just, I write application, it runs, the end, hopefully. And that's where we come in. And that's where we have to abstract all of these problems away.
Interesting. So this is a question that just popped up in my head, and it's not related strictly to Uber. This is actually a feature we have on GKE, and I'm curious about your opinion, specifically because you're working on the node lifecycle working group, right? So GKE have a feature called blue-green node pools. So what it allows you to do basically is bring up node pools under a new Kubernetes version, test if the migration works, if it not, fall back, and then, blue-green, but for the infrastructure side. And to me, like, I've been in the industry for 15 years. So blue-green is application. It's not infrastructure. So what's your thoughts? I'm just curious, like, what do you think about this?
So obviously we don't use GKE at Uber. I know, don't boo too much.
Yeah, it's fine. It's completely fine.
But one of the really tough things, I think, especially with nodes upgrades, is can you effectively test whether a node is in a ready state for an application without risking disruption? That can be, in my opinion, really tough. Like, even if you have like blue-green for the nodes themselves, if you place an application on a node and that node is for some reason not compatible with that application, then you could cause problems, right?
Yeah.
And those problems may lead to actual disruption. This is actually one of the things we've been discussing in the Node Lifecycle Working Group, is this idea as well, not just of this readiness, but also whether a node is ready and schedulable for a workload can actually depend on the workload itself. And obviously in K8s we have like, the node is ready, the node isn't ready, but that's a very binary signal. Some nodes are ready for some things at some times, and may not ever be ready for other things other times. And this has become especially relevant with like AI ML accelerated workloads where, I must be on this node because this node has this TPU or GPU, and I must not be on this node because of that. So blue-green is a great place to start, especially with the current K8 stuff. I really want us to push further in K8s. Eventually, in the long term, I would love us to be in a position where we could express node readiness and node upgrades for a given node based on the workloads that could then be placed on that node. So you could say like, hey, I'm ready for this type of workload. I'm not necessarily ready for this right now. Or I need to be in maintenance for this, but not necessarily this. This granularity. But it's always fun because we always have to balance this against the fact that we can't make Kubernetes infinitely complex.
Yeah, of course.
We can't turn Kubernetes into a big Turing machine.
Yeah.
As funny as that would be.
Yeah, and if I'm reading a little bit into your thoughts, I think that one of the challenges with node upgrades specifically is, are you catching any regressions? Is the performance of the application going to be the same in the new version? Are there any bugs in Kubernetes itself, right? So it's super interesting.
Don't worry, Kubernetes never has any bugs.
No, it doesn't. No, of course not. It's completely bug-free. Yeah.
Lies and slander.
So back to the topic of Uber. In the talk that you have done, the video I watched, you talked about this like classification of services. I believe it was tier 5 to tier 0, right? Can you talk a little bit about that? Like how do you go about like classifying? I guess it's easy. It's like the thing that is business critical is tier 0 and the thing that no one cares about is tier 5, right?
Yeah, basically. So at Uber, we have these 6 service tiers to indicate criticality. So tier 5 is like we have an internal foosball league in Denmark, and the service that runs that, because of course we over-engineered it into a service, is tier 5. Yeah. You know how engineers are. In tier 4 or tier 3, you might find like internal tools that are useful, but you can live without them with pain. Tier 2, you're looking at something that's customer facing, but maybe isn't the core trip flow. So like it could be like a promotion system, a redeeming, that sort of thing. Tier 1, you're looking at things that touch what we call the trip flow. So that's the minimum stuff you need to call an Uber. The car arrived, you get in, you get to your destination, you get out. If your service is needed for that trip flow to run, it's tier 1. And then tier 0 is the infrastructure services that support tier 1. Mm-hmm. So the actual stateless compute platform itself. And we use these a lot at Uber. So migrations, we normally work tier by tier. We start in tier 5 and we work our way down through to tier 0. And that can be useful for us. And I think it's actually one of the things that I think is quite valuable. And like nearly anyone could get this by just labeling even their Kubernetes deployments, in my opinion. Understanding what workloads in your organization are more important and less important. It can both help during incident response because you can know, oh, this is down and that's like really, really bad versus this thing's down, who cares? Especially during a capacity crunch. And on capacity, you can actually start to do very interesting things if you, for example, are okay to expect maybe some downtime of the less important tiered workloads. So for example, we've been thinking about what would happen if you put like high tier workloads on spot instances, for example. Maybe they'll go down every now and then, but if it's a foosball league, who cares? But if we didn't have this tiering system, that would be really, really tough because like we can't put the core trip flow on a spot instance and pray.
Yes.
I mean, we could, but I would get in trouble, apparently. Apparently this is not good engineering practice.
Yeah, and as I joke always when I do my talks is like, if you go out to all your users and ask them, can you tell me how would you in your head classify your service? They will all say it's mission critical, right? Everybody thinks their services are the most important. So here is a curveball question. Where is DNS on this tiering system?
DNS is tier 0 because you know how it goes. Any incident, is it DNS? It's always DNS. The AWS outage we all had recently, the fun of experiencing. Uber doesn't run on AWS, but don't worry, a lot of our suppliers do anyway, so we were definitely involved.
Yes.
That was a fun DNS one. I think I've read like the mini postmortem on that. And of course,
it's always DNS, right?
I have a haiku of that on my wall in my home. It's not DNS. There's no way it's DNS. It was DNS.
Yeah, exactly. So I do have a question about this. I think is coming from the talk as well. Like this, when you had Peloton, you had like a native snapshotting functionality.
Yep.
Which my understanding was basically it allows failing containers to be snapshotted and stored so that engineers can debug them later, right?
Yep.
And the ephemerality nature of Kubernetes makes it slightly harder to do something like this. So how did you kind of solve it in Kubernetes? If solved it is the right term to use here.
Yeah, in Peloton, we had this thing called container snapshotting. And what that let you do is, if a container fails, you get an entire snapshot of the container at the point it failed. And engineers love this because they go in, they read internal Java logs, whatever. They read the state of the file system. Great fun. Kubernetes doesn't natively support this because, Kubernetes is clean and blows up the container very quickly after the pod goes away. So what we did is we added a little sidecar to all of our containers. And this sidecar, all it does is when the container exits, it stops the container being deleted and very quickly jumps onto the file system and uploads it all to a thing called TerraBlob, which you can just basically think of like S3.
Yeah.
It's like Uber's S3. That then sits in TerraBlob, the sidecar exits, and then the pod goes away like normal. But we've now captured the snapshot of what the user wanted. And so users got to keep that feature because this is one of the big things about this migration. We did not want to be in a position where we were taking features away from users. They want to focus on their code. We don't want to be an annoyance to them.
Yeah.
If they have something, it's very hard to take things away once you've given it to people.
Yeah.
Very hard. Mm-hmm.
Yeah, because if you are executing such a large-scale migration, you want to at least try to have a feature parity between the existing platform and the new platform, right?
Yeah.
I mean, that's in theory what most organizations are trying to do. The practice is slightly more difficult sometimes, right?
Look, I'm speaking from theory, okay? Definitely not reality.
Yes. I mean, there is this joke we have at Google, which is there is no such thing as a yellow banana. It's either a green banana or a brown banana. So it's either alpha or deprecated. So stable doesn't exist.
Isn't there a comic from Gumix as well where it shows the two paths at Google? What path 1 deprecated, don't even think about it. Path 2 under construction.
Yes, pretty much. Yeah. So it's either, so one tool will have a deprecated banner and the new one that is replacing it will have an alpha banner.
Yeah.
That's it.
Oh, don't worry. This feels very real to me as well. And I don't even work at Google.
All right. So I do have another interesting question. I mean, you run hundreds of millions of cores, right? A lot of cores. We launched recently the 65,000 nodes in GKE. EKS replied by launching 100K. I was testing the 65K nodes. A kubectl get pods takes 5 minutes, right? As you can imagine, right? So what does it what does that how is debugging inside for Uber? How do you kind of solve this kind of large-scale Kubernetes storage problems?
Yeah, so we measure in CPU cores because we think it's a nicer way than measuring in hosts and nodes because they can all be different sizes. So right now we have just over 5 million cores on our stateless fleet, but then we've spread those. So at Uber, we have over 200 Kubernetes clusters right now. And the idea is that these are broken up into availability zones that we have inside the company, but then our users don't actually see this complexity. So from the stateless compute platform side and from the stateful compute platform side, they hit deploy and they just see that pods have come up somewhere. And then we abstract away all the networking needs to reach you and your logs need to reach you and this sort of thing so that the users don't really have to care. Debugging K8 itself, though, when that goes wrong, can be fun. The first thing we have to do is find what cluster the workload's even on. We have a platform called Grail, and we use Grail a lot inside Uber. Grail is basically a very big distributed graph database that is in memory and represents the current state of the world across the whole company. And the powerful thing about Grail is it has associations between things. So there is an association from a Kubernetes pod to an Uber service, and from an Uber service to maybe a networking group. And you can craft these very powerful queries where you say, look up Uber services that meet these parameters, then follow to the Kubernetes pods that are associated with them.
Oh, interesting.
Then do this, then do this. We've posted a blog post about this before, and it's one of the most powerful features I find inside Uber is the ability to effectively have not just disparate Kubernetes clusters, but even disparate things that aren't even K8s, like proprietary networking groups on the one hand, internal service definitions, Kafka queues, whatever, and associate all of these together in one place where you can query once and jump between these technologies. This is one of the coolest things I think we have here. You know, we have a query catalog. There's thousands of queries that people have written in there. You can do really powerful things for debugging, like show me every pod that has like this property, or show me every pod that's asking for a GPU and the service is also part of this team, because you can follow through.
Yeah.
And so, yeah, a lot of the debugging at Uber from our end as platform engineers, where we actually have touch K8s, we use Grail heavily for it. But from a user POV, we try and correlate and bring together and centralize all of this for them. So their logs get shipped off to our central monitoring system, UMonitor, which is built on M3 and all these other things. And like their metrics do as well. So they as a user, the cluster is just a detail. Like users don't normally care. But yeah, it has been fun seeing people really push the boundaries on how many nodes you can get in a Kubernetes cluster. It's like a new arms race.
Yes, yes. I don't know where it's going to end. We'll see. I like this idea of like being able to correlate across not only applications, but infrastructure and like dependencies and stuff. I find that very powerful because basically if you're an SRE being awakened at 3 a.m. in the morning to fix an incident, the last thing you want to do is like have to stay on Slack and ping people to tell them where is your database, right?
Yeah.
So in one of your, I think it was in the video as well, you talked about during the migration, right? There was the biggest amount of work was on the 10% unique services or special services, right?
Yeah.
Basically, we started by discussing this at the beginning, which is like everybody has the same problem. So 90% of all the applications are exactly the same, right?
Yeah.
So what was the complexity there? Like what makes those 10% kind of special, right?
It depends on the service, but normally they have done something that is critical now to their application, like they've built on top of it, that is simply not something that can be supported portably. So one of the things we saw before was beyond static network ports, which is one issue. We also saw people doing things like, I'll just put these files on the host, and then when my application comes back, I'll just read them later. You know, it's not like I'll get moved to a different host. That's crazy.
No, of course not.
That would never happen. The file system is global and consistent and infinite. That's how it works, right?
Yes.
So with these guys in particular, this can be a huge challenge. The other one as well was there were some applications that were maybe not as stable as we hoped they would be. So, for example, we found some applications on the stateless compute fleet that maybe weren't as stateless as they claim to be. Maybe if you took down too many of their pods at the same time, they had a big incident and it caused a lot of issues. And so for those ones, we had to, at least in the interim, we wanted to migrate them. And we didn't want to wait for them to fix these issues. So, there were initially quite a lot of conditions of, if this service has this label, which means like be really slow on rollouts, then one pod at a time globally, no more please.
Yeah.
And that can take a lot of engineering time, because fundamentally an engineer in our team is spending time to write this path for like 1, 2, 3 services. It's not really a place where we can scale our impact in the way we want. It's why I am so much into pushing to make sure that we do not regress back to this and that we maintain this portability, because we want to scale our efforts. And we can't scale our efforts if we're spending a lot of our time dealing with these special cases, these different services that maybe have these unique requirements. So some of them are always going to exist, but it's all in my head a job of minimization, as few special things as we possibly can, so that we can spend time making the 90% of people happy, and not spend our time just getting the 10% to a basic running state.
Yeah. I did a little bit of work in the consulting space, and that's definitely probably one of where you spend most of your time, right? Like everybody has the same problems, but then there is this like unique use cases that are like usually the ones that take most of the time when you're doing any sort of migration or any sort of architecting, right? It's like, So speaking of unique, I want to jump ahead so we talked a lot about stateless compute, right? So that's kind of was the first phase, I think, of your migration. And there is, of course, batch and stateful workloads. So that would assume everything that has to do with data and large language model and AI. So where are you on that? Not what's next. Where are you on that journey, basically?
Yeah, so right now, obviously, we have all of our stateless fleet now is on K8s. And we're really starting to leverage K8's features, which is really, really cool. So now we're looking at stateful and batch. So right now, the main thing we're looking at is over the next year or so, how much of our stateful fleet can we get onto Kubernetes? But the problems here are different, because stateful workloads have unique challenges and unique architectural issues. One of the big ones is you cannot move a stateful application in the way that you would move a stateless one. You can't just spawn it up here and then shut down the other one immediately and you're good. What could possibly go wrong? Especially because at Uber, we have locally attached disks to a lot of our hosts. So the place that data is tenanted is very important to us. We don't have much in the way of network attached storage for reasons. And so one of the things we found actually is that there are gaps in Kubernetes that have been a challenge for us to work around when we've designed like our stateful migration. So one of them, for example, is eviction in Kubernetes right now is not that mature. You know, we have the eviction API where you can like create an eviction object against a pod, and either at that point in time it will be accepted and the pod will go away if it's within the PDB, the pod disruption budget, or it will 429 and that's it. It's just a point in time decision, right? But that's not really expressive enough, because as someone who runs a stateful platform, I want to be able to say like, hey, I want to evict this workload, and I need to check things that maybe Kubernetes might not know about before doing that. Yeah. Like I might need to check, do I have capacity to put it somewhere else? What's the status of the data on disk? These sorts of things, right?
Yeah.
And with the existing system, you can't really do that. You could like maybe add a finalizer to the pod, but when pods are terminating, a lot of stuff has already happened, especially around networking. So finalizer doesn't really solve for that. So one of the things we've been looking at, which solves this for hopefully more people as well in the future in the Node Lifecycle Working Group, is this concept of eviction requests. And what an eviction request does is it lets you say, I would like to get rid of this pod at some point in the future. And so as someone who wants to get rid of the pod, you create that eviction request. And then you have stakeholders called interceptors. And interceptors annotate the pod with, hey, I want to be told when someone wants to evict this pod. And then one by one, on the eviction request, they appear in a list. They are signaled to, hey, you can do your thing now. And when you've done your thing, just say that you're completed, and we will move on to the next interceptor.
Got it.
And that now is a much more powerful verb, because instead of a point-in-time decision of, can I evict you right now, 429 or 200, that's it. You can say, I would like to evict this pod at some point. Please do your business logic. Please move your data. Maybe it will take you a few minutes. Maybe it will take you a few hours. Maybe it will take you a day if you've got a huge piece of data. And this allows you to do effectively You can defer pod eviction to a point in time where it makes sense to your business. If the pod needs to be evicted now because it's a bad host, you can progress it more quickly. You can also just understand and visualize this a lot easier in Kubernetes, because right now, obviously, eviction objects don't really exist. Like, you create one and it blows up with the pod.
Yeah.
It's special. But with this, you can actually model like, oh, this pod is someone's trying to evict it because of XYZ ABC. And the status right now is that this interceptor, maybe one that's like moving the data, is copying the data to a new replica. And then once that's done, it will do this, and then it will go away. That, I think, is a lot easier as well for users of K8 to see and understand, especially when we're modeling it as resources inside the cluster. So right now, we're hoping, we didn't hit the release for December, unfortunately, but we're hoping that next release we can get at least a KEP in and maybe a nice alpha. Within Uber, we're pushing this really hard. We've already managed to get a working reference implementation of the KEP online and rolling, and we're actually going to use that in our migration, like starting in about January, as a production part of it.
Nice.
Because it's outside of just Kubernetes itself, it's a really good primitive, and it's really powerful, and in my opinion, it's not too complex as well.
I can see how that would be super useful. So a follow-up question. Will that mean also that you can have some sort of signal inside the container that the application can intercept and do something with it, like close connections or, commit data to disk? You see what I mean?
Yeah. What you could do is you could just have an interceptor as the last one. So interceptors have to be able to look at the cluster, but you can do that with service accounts, right? You could have an interceptor on the pod that the pod itself's container is looking for. And when it comes up, that could be the signal to the application of, hey, close your connections, shut yourself down.
Yeah.
Or, get yourself ready to shut down, I should say, because you shouldn't shut yourself down because then the pod goes away anyway.
Yeah.
And then progress. But yeah, all you need to be an interceptor is you need access to the cluster to see eviction request objects, and you need to make sure on the pod you're patched in as, hey, I'm an interceptor for this pod.
Yeah, that's certainly better than, I'm going to tell you this. This is, I think, a funny story. I worked on a project a long time ago, which by long time ago, I mean 2018. So, right, not that long ago.
I hadn't even graduated in 2018. So for me, this is a lifetime ago.
So what this project was basically is a customer that had a Node.js app with a known memory leak issue, right? And they debugged it down to the very simple fact that after a certain number of requests served from that particular app, the memory leak issue happens, right? So what was the solution? The solution was, we're going to put a sidecar that counts how many requests the pod is processing. And after the critical number of requests, we kill the pod. So I hope they moved away from this, but that was one of the funniest implementations I have seen.
If your viewers could see my face right now.
Yeah.
Could see my face.
Every time I tell this story, people go like, what?
I've definitely seen some fun implementations in the past. One time I saw a team who wanted to do custom control of node readiness. And their solution was not node readiness gates. Their solution was just to crash loop the kubelet until they were ready.
Oh, of course.
I thought that was an interesting implementation approach. If it works, it works. Right?
I mean, that is technically a readiness if you always reply 400 until you are ready, right?
Yeah, exactly. This is the next level. So yeah, next feature in Kubernetes, the kubelet crash loops itself unless it's ready.
Yeah.
No, maybe not.
So speaking of fun implementation, you're working on something. It's an LLM wrapper. I'm reading what you wrote. So then you tell me. So it's an LLM wrapper that pretends to be a Kubernetes API object, works with kubectl, hallucinates objects into existence when you try to get them. My question is why?
Under the Fifth Amendment of the United States Constitution, I don't have to answer that.
No, you're not American. Come on.
Okay, yeah, fair enough. No, damn it. So this is what I would call a moment of weakness at 7 o'clock in my house, when I realized maybe that I could do something, and I don't stop to think about, should I do it? So what this is it's a Go binary that's hooked up to an LLM, and the LLM's instructions are, you are a Kubernetes API server. You must respond with fully formatted JSON responses to HTTP requests. You will be given the URL and the payload from the request. You must not add any extra commentary or the JSON parse rate. Then you run that as a HTTP server, and you pipe it all back to the LLM. And then you make a kube config that points your kubectl directly at it. And you can actually go further. I tried with kubectl. That was very funny because I did like a patch against a deployment that didn't exist, and the LLM hallucinated it into existence.
Sure.
So say it was patched. Then I went to get the deployment, and it was slightly different from what I just patched. Because I created a deployment object, and then I did get pods, because obviously there's no actual Kubernetes behind this. There's no controller manager, no etcd, and of course the pods had suspicious IDs like 1, 2, 3, 4, 5 and A, B, C, D, E.
Of course.
Then, in another moment of weakness, I thought, what happens if I connect a kubelet to this? That got interesting. It spawned about 10 copies of Nginx. Then it just started pulling random images off of Docker Hub for all sorts of applications.
What can go wrong?
What could go wrong? You know, I'm just being a good steward, letting people run stuff on my computers. It's very charitable of me. So now, by the time this recording goes up, it should be on a website actually, I decided that the best thing to do would be to buy a domain name and put it on a public website, because what could go wrong with that?
Of course.
So if you go to, what is it called? I think it's kubegpt.org. Not while we're recording, because I haven't turned it on yet, but I'll turn it on before we publish this.
Okay.
You can get a kubeconfig, and if you use that kubeconfig against your kubectl, you will be connected to a cluster that is not a cluster at all. It's just an LLM pretending to be one. And you can try and do a deployment on it, and maybe it will work. Maybe the LLM will hallucinate it into existence. Maybe the LLM will do something else entirely and turn it into a stateful set because it feels like it. Who knows?
I mean, this could be a good learning tool. You know what?
Yeah.
It's only a matter of time that somebody will use this to learn how to pass the CKA certification. I'm quite sure.
Can I, how many things does it have to pass for me to get the certified Kubernetes badge? This is my follow-on question.
That's a very good question. I think you will have to ask the LLM to figure that out, right?
Yeah. I'll send it a config map, and the key will be replace this value with how many things I have to pass to get the Kubernetes certified badge.
There you go.
This is prompt injection.
Yes.
I guarantee that the moment people realize this domain exists, that my LLM credits are going to die very quickly. But you know what? Worth it.
Okay. So, I mean, look, I was in a conference this weekend and somebody was talking about something I learned for the first time. There is an open source project called OS Query. And what OS Query allows you to do is query your operating system metrics as a SQL database. I mean, why would you want to do that? I have no idea, but, you know, whatever.
Love it.
All right. So I do have one last question. This is, before you give me your closing thoughts or anything you want to close with. You are British, so you have a little bit of authority over the English language. Is it kubectl or kubectl?
Kubectl.
Okay.
I'm sorry, but this is the way. And if you don't like it, then you'll have to come on the podcast yourself and explain to Abdel why I'm wrong.
It's fine. We're not publishing this episode. It's okay. Have a good day. I'm just kidding.
It's over. It's over. Reputation in the mud. Look, as I've said to people in Denmark before, when I make a mistake with English, it's really funny because English is my native language, but it's not there. So I just go, actually, as the native speaker, that is completely okay. And you guys can't say anything back about it because you learned it in school. I learned this when I was born.
Well, I mean, in the same context, I could also make mistakes and say, you know, English is not my native language, so I'm sorry. It can go both ways.
I should try doing that as well.
Also, you say, oh, by the way, I have been living in Denmark for a very long time. I kind of forgot about English.
Yeah, exactly. It's I've got too used to really weird words for things and speaking from my throat.
Awesome. So, Lucy, this has been a fun discussion. I learned a lot. Any closing thoughts? Anything you're excited about? What's going on? Are we going to see you at KubeCon Europe?
Oh, absolutely you are. I've got 2 talks at KubeCon US this year.
Awesome.
I'm going to be on an AI/ML panel with a few folks from Google, of all places, among others.
Okay.
And then I also am going to be doing a talk with Sandeep from Gen, where we're going to be breaking into a Kubernetes cluster live on stage and doing privilege escalation and all these fun things.
Awesome.
So both of those should be great fun. And outside of that, I'm looking forward to when we hit 10 million calls on K8. I want the 8-figure number. We need to get the stateful fleet on there, and then we can get there, I believe.
All right, so this is your open invitation when you hit that number to come back on the show and tell us all the fun stuff you have learned.
I'll bring cake.
All right, cool. Sounds good. I'll be coming to Aarhus to celebrate that in this case. Because last time I was in Aarhus, there was cake for the 10 years anniversary of Kubernetes, right?
Yeah, absolutely. And if you want to be physically here for cake, just a heads up, you could just join Uber, uber.com/careers.
Awesome. Yeah, that's great. We're also going to make sure that the links to your talks, because this is going to air after KubeCon North America, so we'll make sure that we include the recordings.
Yep.
And there is also your LinkedIn profile. We'll have that. And then there is also lucy.sh. I really like the domain.
Thank you.
That you can go check to follow up on what Lucy is up to, upcoming talks that have been done already, etc., etc. Awesome. Thank you so much, Lucy.
Thank you so much. It was lovely to talk to you as ever. Look forward to seeing you. You're not at KubeCon this year, are you?
No, not North America. I'm going to be in Morocco. It's warmer
Abdel.
and better food.
Abdel, listeners, I need you to all collectively boo right now. All together.
Yes, but I will see you in Europe for sure.
Oh, absolutely. Look forward to it.
Awesome. Thank you. That brings us to the end of another episode. If you enjoyed the show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on social media at KubernetesPod or reach us by email at kubernetespodcast@google.com. You can also check out the website at kubernetespodcast.com, where you will find transcripts and show notes and links to subscribe. Please consider rating us in your podcast player so we can help more people find and enjoy the show. Thanks for listening, and we'll see you next time.